Okay, I'm just going to talk you through this question. So we've got a triangle which vertices A, B and C, and hopefully you can see the coordinates of the points up at the top there. The solution. Again, we're still following the same format, so point gradient equation. And this is part A. Okay, if I look at the question, I've actually only got points, so it's probably helpful to actually just draw a very quick sketch of the points so I can see roughly what I'm dealing with. So I'll just do that down here. I'm just going to mark the origin with that, okay, a wee O. I'm not going to draw out an X and a Y axis. Like I said, I'm just going to mark the origin. So -1, 6 for point A is -1 along, 6 up. So it's somewhere up there. Point B is -3, so further along and a wee bit down. So that's A, which is -1, 6. This is B, which is -3, -2. And then we have C, which is 5 along, 2 up. So 5 along, 2 up. So somewhere about there. Okay, so just a quick sketch gives me an idea of what I'm dealing with, and it also allows me to annotate the sketch, and you can see it's not perfect. Okay, I'll just move that there. Right, okay, so find the equation of the median from C. So straight away, we're coming from C. The median goes to the opposite side and cuts it in half. So I can mark that on my diagram, so I know that I can see what I'm actually dealing with. Okay, so if I look at the point, well, the point is going to be the midpoint of AB. So what I want to do to find the point is add my two x coordinates together and divide by 2. So -1, add -3 is -4. -4 divided by 2 is -2. Add your y coordinates together. 6 add -2 is 6 take away 2. 6 take away 2 is 4. 4 divided by 2 is 2. Now, it's just a rough sketch, but I can see that that roughly ties in with where that point is. Okay, -2 along, 2 up could potentially be the midpoint of AB. If I'm getting coordinates of 7, 8, 7, 8 would be along here. I know that that's not correct. So this isn't an exact check, but it's roughly in the region of the X and Y axis that we would expect. Okay, so from there, gradient, we've got 2 points now. We know that this point here is -2, 2. So it's just the basic formula, y2 minus y1 over x2 minus x1. At this stage, guys, you've got a few different ways to find the gradient. The easiest way is the way that you were taught in National 5, and that was just your y2 minus y1 over x2 minus x1. So if you've got 2 points, that's how you find the gradient. If it mentions an angle, then you're using m equals tan theta. If it's talking about perpendicular, as you'll see in the next question, then you're probably going to use m1 times m2 equals -1. Okay, so it doesn't really matter what one you put as x1, y1 and what one you put as x2, y2. In this example, to calculate the gradient, I'm just going to make C my x2 and my y2. So it's going to be 2, take away 2, all over 5, take away -2. So 5 take away -2 is 5 add 2. So I'm going to get a gradient of 0 over 7. What that means is that the median is actually a horizontal line. So in the last lesson yesterday, there's a wee video on vertical and horizontal lines. Hopefully we should now be aware, and this came into National 5 as well, that when you have a gradient of 0, you have a horizontal line. So at this point, we can, because we've got a gradient of 0, we can substitute into y minus b equals m times x minus a if we want. But we don't actually need to. All horizontal lines have the format y equals a number. Okay, so they all have a format y equals a number. Now the number is just the y coordinate of any point on that line. So in this example here, we've got C, we've got the midpoint, and you can see that both the y coordinates are 2. Okay, I said this a lot to my classes when they're doing N5. If you are talking about a horizontal line, every single point has to be the same distance from the x-axis, i.e. it has to have the same y-coordinate. So it's the same number of points up or the same distance below the x-axis. If you put points on a horizontal line, so if you physically actually mark the points in a line, what you'll notice is all the y-coordinates will always be the same, and that's why it has the equation y equals a number, y equals the y-coordinate of a point on that line. Okay, so that's A. Looking at B then. So find the equation of the perpendicular bisector of BC. Again, my diagram's going to help me here because BC's here. The perpendicular bisector is going to be something that looks roughly like this. And remember, perpendicular bisectors don't come from vertices. Okay, so you'll notice that that line is not going to go through a perpendicular bisector. Cuts a line in half and at right angles. Okay, so again, the point, the gradient, and the equation is what we're looking for here. Point, again, it's going to be midpoint. We know that a perpendicular bisector, if you bisect something, you cut it in half. So again, adding your x-coordinates together, 5 add -3 is 2, 2 divided by 2 is 1. Adding your y-coordinates together, 2 add -2 is 0, and dividing by 2, 0 divided by 2 is 0. Gradient. Okay, so I now know that this point here is 1, 0. I don't have another point in that line. Like I said, it doesn't go through A. So I can't use y2 minus y1 over x2 minus x1. But again, we've got that word perpendicular, and that immediately should make you think of m1 times m2 equals -1. So what I'm going to do is I'm going to calculate the gradient of BC, and I'm just going to mark this with a wee kind of BC in the bottom right-hand corner of the M. Okay, again, I'm going to count C as my x2, y2. So 2 minus -3 becomes 2 add 3, and then 5 take away -2 becomes 5 add 2. So we get a gradient there of 5 over 7. Now that's not the one that we are interested in. Oh, there's a wee mistake there, isn't there? So it's 2 minus 2. Yeah, so it's 2 add 2 on the top. Apologies, I'm getting my x and my y coordinates messed up. So that would be 4. And then we would have 5 take away, yeah, that probably looks a wee bit better, so it's going to be 5 add 3. So my mistake there is I just got the points mixed up. So it's 2 take away -2, which is 2 add 2, and then 5 take away -3, which is 5 add 3. So we're going to get 4 over 8. And that's going to simplify down to a half. Okay, so the equation, not quite at the stage where we can go to the equation. This is the gradient of BC. We want the gradient of the perpendicular bisector, so we're going to use m1 times m2 equals -1. So that means that the gradient of the perpendicular bisector, which we can just mark with that wee symbol, it's like a wee right angle. All I'm really doing is inverting that and then multiplying by -1. So I know that the gradient of the perpendicular bisector is -2. Okay, so the equation then, got our point, got our gradient, it's y minus b, y minus 0 equals m times x minus a. So we get y equals -2x, add on 2, and again I'll just collect all the letter terms on the left hand side. Okay, as I've said before, checks all the way through this are important. This point should lie on this line. So if I've done this correctly, then when I substitute that point into that equation, it should come true. So let's just check that. And we don't have to necessarily write that down. 0 add 2 times 1 is 2. 2 times 1 is 2. So we know that that's correct. It's not ideal because the point I've subbed in is the point I've used to check it, but it's a rough check. Okay, so finishing it off with part C, we've got to find the point of intersection of the two lines. Okay, so the two equations I'm dealing with for part C, the two things I'm dealing with for part C are y equals 2 and then y plus 2x equals 2. Okay, so simultaneous equations is not required for this one. We've got the y coordinate is y equals 2. We're just simply going to sub that in and solve it for x. So when y equals 2, we'll have 2 plus 2x equals 2. Again, just solving that, you're going to get x equals 0. So the point of intersection nope, not negative 2. It's simply 0, 2. And again, I can check that. Okay, we've got two equations. Obviously, we can't sub it into this one. If we did, we would get it ringing true because 2 does equal 2. But a much better check is to check it in this one. So let's check to see if that's the case in the second equation. So y, which is 2, plus 2 times 0 must equal 2. And 2 add 0 does equal 2. So I've not got that correct.